In addition to the shift operators from the previous lesson, there is a family of bitwise logical operators that you can use to set, clear, and test the setting of bits. Most often this is done between a bit pattern constant and the contents of a register, and that's what I use in this lesson to demonstrate how it works. These operations can be performed on integer data of any size, 8, 16, 32, or 64 bits. The examples here use 8-bit registers to make it easier to read the bits. This function demonstrates the use of the AND operator. It does so by first displaying the two binary values. Then it ANDs the two values together and shows the result. The two values are ANDed together bit by bit. This is known as a bitwise operation. By comparing the two input binary values with the result, you can see that for a 1 to appear at any given position in the result, a 1 must exist at that position in both of the original values. This operation is often used for masking. That is, you can construct a mask with 1 bits for the positions that you are interested in, and ANDing a value with that mask will leave only the bits that you have interest in. I'll have more about this in a minute. The OR operator works the same way, except that a 1 bit in a given position in either of the input values results in a 1 bit in that position in the result. This operator is particularly useful for setting bits. If you construct a value that contains 1s only in the bits you wish to have set, then ORing it with your value will set those bits to 1 and leave all the others unchanged. The third standard operation is called exclusive OR. For a bit in the result to be set to 1, a bit must be 1 in either of the two input values, but not in both. That is, a 1-bit results only if the corresponding bits of the input values are not the same. The practical uses of exclusive OR are a bit more exotic than the others. It's often used to combine colors to make temporary displays. For example, you've seen rubber band type lines that move around the screen but leave no trace behind. That can be done by exclusive ORing the line in place. Then when you exclusive OR it again in the same place, it erases the line and restores things to their original values. There is one more. It's the NOT operator. The NOT operator is a unary operator. That is, it works on a single value. The operation of NOT is very simple. It changes all the 1 bits to 0 and all the 0 bits to 1. That is, it produces a 1's complement of a number. If you want to take the negative of a positive number or the positive of a negative number, you can use the NOT operator and then add 1. That gives you the 2's complement. The result is the same as if you had multiplied the number by -1. Those 4 are all the basic Boolean operations, but there is an opcode for a special version of AND.